So that's not the circuit I want. That's the one I want. Okay, so what you see there is a battery that is connected to a resistor. That thing over here is a resistor. And there is a voltmeter connected that is measuring the terminal voltage of the battery, right? That's the language that they use for this concept, the terminal voltage of the battery. Now that battery is a realistic battery, it's a real battery, it's not an ideal battery, which means that it can have some internal resistance. In general, it will have some internal resistance. The flow of the ions inside a battery does have some resistance to it. So whenever you connect the battery to a resistor, there will be some of the resistance of the circuit will be inside the battery. And that's what explains why sometimes when you have been using a battery for a while in any appliance that you want, if you hold the battery, if you touch it, it would feel a little warm. That's because some of the resistance of the circuit is inside the battery. And what do resistors do? When there is current flowing through a resistor, what happens to the resistor? Well, the resistor is going to use up an amount of energy per second equal to, you can use different equations, I squared times R or delta V squared divided by R. But the message is that that resistor is dissipating energy. Okay, the energy is coming from the battery itself, but the resistor is dissipating energy. So let's see what happens. What would you expect to happen, for example, what would happen to the difference to the terminal voltage of the battery if I decrease the internal resistance of the battery? So for the internal resistance that you can see there, which is 6.86 ohms, the voltage, the terminal voltage of the battery is 5.81. Notice how that is different from the 9 volts that would be actually written on the battery. Right? That's less. What would you expect to happen to that terminal voltage if the resistance goes down? If the internal resistance goes down? Notice what you're measuring there. Make sure that you're clear about what you're measuring there. What you have is a battery here with some internal resistance, and this is all inside the battery. And now you're connecting, well, this thing is connected to a resistor out here. This one you can call R internal. And you're measuring the voltage between this point and that point. Point A and point B. Right? So, in general, why would you expect the terminal voltage to be less than the EMF of the battery? The EMF is this, difference in potential when you go from the short line to the bigger line. Why would you expect that terminal voltage to be less? As you can see, it's 5.81, where the EMF is 9. As you move from B to A, you're going to cross two elements, right? You're going to cross we're dividing a real battery into two separate compartments. Of course, this is all mixed together in the chemicals and everything together is what gives you the EMF and the internal resistance. But we can just split it conceptually into two parts. So as you move from B inside the battery, you're going to cross the EMF of the battery, and that brings your potential up to epsilon, right? But as you cross the internal resistor, remember that the current flowing here, there is a current flowing in this circuit. So as you cross that resistor, your potential is going to drop. By how much does it drop? It drops by the total amount of current flowing out of the battery through this circuit multiplied by the internal resistance of the battery. Okay? So the terminal voltage is no longer epsilon, is epsilon minus the current flowing in the circuit multiplied by the internal resistance. And that is less than epsilon, obviously. Okay? So that's why you see that number being less than 9 volts. Now, what would happen if the internal resistance of the battery goes down? Then that equation clearly tells you that when the internal resistance of the battery goes to 0, the EMF, the terminal voltage of the battery should go to the EMF. Okay? So if as I move that, let's see if I can do it from here. I'm going to erase this. As I move this thing down, you would expect this to go towards, to grow. As the internal resistance turns towards 0, you would expect that terminal voltage to be 9 volts, which is the case of the ideal battery. No internal resistance, the voltage measured on the terminals will be exactly equal to the EMF of the battery. Okay? So as you increase it, the terminal voltage goes down. Now let's leave it at some value here. What happens to the terminal voltage of the battery, of a realistic battery, with some internal resistance different from 0? What happens when you change the resistance that you're connecting in the circuit? If I were to move that slide towards higher values of the resistance, what would happen to the terminal voltage of the battery? Would you expect that number to go up or to go down? To go up? How do we know that? That's right. Let's go back to that, to the equation that I just wrote. I wrote that the terminal voltage is going to be equal to the EMF of the battery minus the current flowing in the circuit multiplied by the internal resistance of the battery. If I change the external resistor, if I make it go up, what happens to to these three variables here in this equation? Epsilon, does epsilon change? Epsilon has nothing to do with the resistance that you put outside, right? That's just a property of the battery. So epsilon does not change. Does the internal resistance of the battery change if I change the resistance outside? That has nothing to do with it. But the current does change. If I increase the external resistance, the current goes down in the circuit. So if the current goes down in the circuit, what's going to happen to epsilon minus I R internal? That number goes up, right? So if the external resistance goes up, then the current goes down. If the current goes down, the terminal voltage is going to go up, right? I don't know why it always closes. So let's do that. Move the resistance outside from 12.5 higher and see what happens to the terminal voltage of the battery. It's moving towards 9 volts, right? Okay. All right. So that's something I want to show you about the internal resistance of the battery.